Good morning friends. Today we are going to see one of the sorting technique called as selection sort. Selection sort, the name itself tells that we are going to select one element from the unsorted list and we are going to enter that element into the sorted list. This type of sorting technique is called as selection sort. So if you take the selection sort, it is one of the in-place comparison sorting algorithm. So what is this in-place comparison sorting algorithm? So we are taking one element by one element and we are inserting that into the particular position. And when compared to all other algorithms, it is also having the order of n squared time complexity. That's why it is not at all suitable for the large lists. And generally, it performs worse than the other sorting technique like insertion sort. Insertion sort and selection sort are not at all suitable for the large lists of the data. And the selection sort, basically the advantage when we are considering its simplicity and its performance advantages when compared to the other complicated algorithms that we are having. Example, whenever we are having very small auxiliary memory and we want to sort the elements, there this selection sorting algorithm is much suitable when compared to the other sorting algorithms. And if we see this algorithm, like previous insertion sorting algorithm, this algorithm also divides the list into two sublists. One is sorted sublist, another one is unsorted sublist. And if you take the sorted sublist, it will be built from the left or the front of the array. So we are bringing up the first or the least, whatever the least or the highest element what we are preferring based on the sorting order, it will be placed in the starting position. Then we are going to the next position. Like this, we are going up to the last element until all the elements in the array are sorted. So the main aim of our algorithm is, in the unsorted list, we want to find out what is the smallest element and we are going to swap with the element that we are placing. So this type of mechanism, that is, this type of algorithm is used for exchanging the leftmost unsorted element with the least element that is present in the unsorted list. Once again, I am repeating, we are going to find out the smallest element that is present in the unsorted sublist and we are going to exchange that element with the leftmost unsorted element. And when we are considering the selection sort, the time efficiency of the selection sort is quadratic because it is having the multiple loops. So it is a quadratic time complexity, and there are so many sorting techniques which are working under the unsorted, that is quadratic time complexity, and when compared to those algorithms, it is having the better time complexity. And one thing that we are distinguishing the selection sort from other sorting techniques is, whenever the minimum number of swaps that we are performing n minus 1 in the worst case that we are performing, that is, the minimum number of possible swappings in the worst case are less in case of the selection sorting technique. Now we'll take one of the example of selection sort. Before discussing about the individual passes that we are having in the selection sort, we'll see the basic example that we are having. So initially consider these are the elements. So at first I am considering the first element and I am finding out what is the smallest element that is present in the remaining list. In the complete remaining list, initially this complete array is considered as an unsorted array. The leftmost element present in this one is this 4. And I want to find out the minimum element that is present in this one, and I want to swap or exchange the smallest element in the unsorted array with the leftmost element in the unsorted list. So now if we take the least element that is present in the unsorted list is 1. Now I am going to swap this one with 4. 4 and 1. Now only 1 is the sorted list and the remaining elements are unsorted list. Now I am considering the 3 and I am finding out the least element that is present in the unsorted list. The least element that is present in the unsorted list is 2. So I am swapping 2 with the leftmost element in the unsorted list, that is 3. So 2 is swapped with 3. Next. Now the sorted list is 1 and 2. Unsorted list is remaining elements. Now I am finding out what is the least element that is present in the unsorted list. The least element that is present in the unsorted list is 3 itself. So 3 has to be swapped with the 3 itself because 3 is the minimum element and 3 is the leftmost element that is present in the unsorted list. That's why logically there was no swapping in this case. Now 1, 2, 3 is a sorted list and the remaining elements are unsorted list. Now I am finding out what is the least element that is present in the unsorted list. The least element that is present is 4. Now 4 is swapped with the leftmost element in the unsorted list, that is 10. 4 and 10 are swapped. So next I am considering the remaining unsorted list and I am finding out the minimum element. The minimum element that is present in the unsorted list, that is consisting of 12, 10, 5, 6 is 5. Now I am going to swap the 5 with the leftmost element 12. And next the sorted list now was these 5 elements. And the unsorted list is 10, 12, 6. The smallest element in the unsorted list is 6. So 6 is swapped with the 10. Now this orange color is specifying the unsorted list and in sorted list. And in the unsorted list we are having 12 and 10. So out of 12 and 10 the minimum number is 10. Now 10 is swapped with the 12. Now the orange colored elements are the sorted list and only one element is there in the unsorted list, that is 12. Only one element is there, so there was no need for any other swapping or exchanging. This is what the thing that is happening. But we are not seeing what is actually internally happening and how to find out the minimum element that is present in the unsorted list. This is the basic example. But to know what is happening in each and every step, individually we will see one pass. Okay. So now if you see in this one, we are finding out the smallest element at I equal to 0 in this pass. At I equal to 1, we are finding out the smallest element. At I equal to 2, we are finding out 3, 4, 5, 6. That means from I value is equivalent to the 0, I value is equivalent to 6, we are finding out the smallest elements. And when we are seeing that particular thing every time, when we are taking the unsorted list, we are selecting the minimum element from the sorted list plus 1. Here if you take, it is 0. Now you are finding out the smallest elements in this particular list. Like this, the I value is varying from 0 to 6. Now we'll see the individual passes. This is pass 1, pass 2, pass 3. Like that we are having the individual passes. To the pass 1. In the pass 1, I want to find out the minimum element. I want to place it into the I equal to 0. So initially the minimum element has been considered as a 4. Now 4 is compared with 3. Even now the minimum element is not 4, it is 3. Now minimum element 3 is compared with the next element 2. Now the minimum element is not 3, it is 2. Now 2 is compared with the 10. Minimum element is 2 only. 2 is compared with the 12. Minimum element is 2 only. 2 is compared with 1. Now the minimum element is not 2, it is 1. Now 1 is compared with 5. Minimum element is 1. 1 is compared with 6. So minimum element is 1. At the end of the pass 1 that we are getting is the minimum element is 1. And we are swapping that minimum element with the leftmost element. So we are swapping 4 with the 1. Now this is the sorted list and the remaining elements are the unsorted list. In the next pass, we are taking I equal to 1. Now 3 is considered as a minimum element. 3 is compared with 2. 2 is the minimum element. Next 2 is compared with 10, 12, 4, 5, 6. 2 is the minimum element. So 2 is swapped with the minimum initial thing, that is leftmost element, what we have considered as a 3. So we are swapping the 3 with 2. Now this is the sorted list and this is the unsorted list. And then the next I equal to 2. So minimum element is considered as a 3. Now 3 is compared with 10, 3 is compared with 12, 3 is compared with 4, 3 is compared with 5, and 3 is compared with 6. Even after all the comparisons, 3 is the minimum element that we are having. So initially we have considered it as a 3 and minimum element is also 3 and it is the leftmost element. So there was no swap that is needed. So this is the sorted list and this is the unsorted list. In the phase 4, if you see, I equal to 3. So minimum element is initially considered as 10. 10 is compared with 12. No, 10 is minimum. 10 is compared with 4. Now the minimum is 4. 4 is compared with 5. Minimum is 4. 4 is compared with 6. Minimum is 4. Now 4 is swapped with the leftmost of the unsorted list, 10. So this is the sorted and this is the unsorted. And in the fifth phase, I value is considered as a 4. So now 12 is considered as a minimum element. So 12 is compared with 10. Now the minimum is not 12, it is 10. 10 is compared with 5. 10 is compared with 5. It is the 5 is the minimum element. 5 is compared with 6. So 5 is minimum. So 5 is swapped with this 12. Now this is the sorted list and this is the unsorted list. Next we are going I equal to 5. 10 is considered as a minimum. 10 is compared with 12. 10 is minimum. So 10 is compared with 6. 6 is the minimum. Now the minimum element is 6 and leftmost is 10. 6 is swapped with 10. Next, in the last phase that we are having, I equal to 6, 12 is considered as a minimum. So 12 is compared with 10. So 10 is the minimum element. 10 is swapped with the 12. So I value is varying from 0 to. Now we'll see the program for this one. Initially we have taken the size and we have taken the elements and we have read all the elements. Now when we are considering this particular value, the number of passes that we are having is I is equivalent to 0, I less than n minus 1. When we have taken 8 elements, 6 passes came from I equal to 0 to I equal to 6. That means I less than n minus 1 is I less than or equivalent to n minus 2. And initially I have considered the 0th element as a minimum element. And from the first element to the last element, I have found out what is the minimum index here. Minimum is used for the minimum index. So this minimum index is swapped with the leftmost element in the unsorted list we are doing. Now when we are considering this particular algorithm, the J value is specifying about the unsorted list that we are having. So the unsorted list will be starting from I plus 1 and it is going up to the last value that we are having. So initially we are considering the minimum value as I value. That means in the first pass, the minimum value is A of 0. In the second pass, it is A of 1. And in the last pass, in the previous example, it is A of 6. Like this, the J value is varying from I plus 1 and it is varying up to n. And now I am checking A of minimum is greater than A of j. If A of minimum is greater than j, the new minimum is the value present in the index j. When we are comparing, when we want to exchange, when we are exchanging was if the minimum element is not equivalent to the leftmost sub-element of the unsorted array, then only we are swapping this one. This is the actual logic that we are having for the insertion sort. When I equal to 0, the zeroth element will be the least element. then when I equal to 1, in the first position element will be coming. So this is insertion.